the sound, but something has just gone goofy. Okay, well, first of all, you don't have a USB microphone or headphones, so put the sound system on the right setting. Okay. That should do that, and now let's see what I can do with this video. Get it to play. I don't know, things get weird sometimes. Did you ever notice that? I know it's not just me. Alright, where are you? It's hiding on me. MP3, so I better play. An electric field will transversely squash. You just saw that. That was a different video. So if this video doesn't play, I will know that my computer hates me. Let's see where. Here's okay. Enjoy. Conventionally viewed the formation of a solar-type star and planets from a cloud of gases and cosmic dust takes on the order of several hundreds of millions of years after accretion. An Earth-like planet supposedly takes another 1 or 2,000 million years, 1 to 2 gigayears or eons, to develop a stable lithosphere, which, when formed, allows the much slower evolution of a viable biosphere from the materials and energy available at the planetary surface apparent. To us, these processes seem too slow and rely too much on random occurrences to be viable. However, the processes forming stars and planets and leading to living things may proceed much more rapidly. Our cosmogony employs to accomplish change. These procedure changes, which are much more powerful and are highly selective. Electrical force, as measurable by the repulsion between two electrons, compares with the apparent gravitational attraction of the same two electrons in the ratio of 10^36 to 1. Conventional models of cosmic processes employ almost exclusively the trivially force termed gravity to produce and govern the universe. Electricity is a greater sculptor of change, because it operates more variably within a given cosmic setting. A simple lightning bolt can cause extensive surface damage, liberating megajoules of energy within a few meters of surviving observers. Only thousandths of a second are involved in the event, yet to an undisturbed geological surface may be the setting for a large number of biological mutations provoked by a radiation storm of cosmic origin. What gravity is supposed to accomplish in eons, electricity could quickly accomplish before the eyes of the earthly observer. Driven by the powerful motivator electricity, quantivolution becomes not only possible, but also essential. Furthermore, understanding of electricity's role provides a powerful new, unified explanation of the most observable phenomena. If the evidence cited in Chapter 1 has permitted us to proceed viewing the developing solar system as Solaria Benaria, and similarly if in Chapter 2 we end up viewing stars, and in particular the sun, as an electric phenomena, then we can hope to inquire about the timescale over which the solar binary developed. To be more specific, we may have a stellar binary which develops over a short interval through some of the most significant phases of the history of the solar system. To tackle the problem of chronology, we shall, as we have done before, look to the skies for the crucial clues. We must, in so doing, introduce a seemingly radical conception, one which we feel can be defended with the evidence to follow. We assert, in line with the past chapter, the stars take their properties less from the material which they contain and more from the electrical difference between the cavity which creates the star and the surrounding medium of electrified space. See space infracharge. Translated into more common astronomical language, the luminosity of the star depends upon its galactic environment rather than upon the amount of material which it contains. See behind, and to technical note B. The conventional notion that the more luminous the star, the more massive it is, was induced by Eddington. from the analysis of a small sample of binary stars. As we interpret the same data, the more luminous the star, the more it transacts with its companion, and so the companion completes its orbit more rapidly. See Technical Note D. Unfortunately, Eddington's mass-luminosity relationship is well established in astronomical formalism. There is a problem inherent in Eddington's method of amassing the binaries. He calls upon gravitational force and nothing else to bring about motion within the binary system. The problem is compounded when luminosities are introduced as a way to measure mass in non-binary systems. Luminosity can only be known where the distance to the star can be measured. Star distances are computed using the annual parallax produced by viewing the displacement as the Earth orbits the Sun of any nearby star against the background of very distant stars. The parallax measurement involves measuring the minute angle at the apex of an isosceles triangle, whose base is the diameter of the Earth's orbit about the Sun. Parallax angles are very small. The closest star, Alpha Centauri, is only displaced through 1.52 greater than arcseconds, or 1.52 arcseconds over the year. This parallax, the largest, was not measured until 1839. R. H. Baker. Parallaxes are difficult to measure, and they cannot be determined for stars further from Earth than 652 light-years. Such a small distance encompasses only 1,000th of the sphere of stars under close observation by astronomers. Thus, the majority of reported star distances and luminosities are derived by theory rather than measurement. Of the 21st magnitude stars, apparently brightest stars in the sky, only 5 are closer than 26 light-years. The next 5 take us to 84 light-years, the next 7 to 217 light-years, and the next 5 to the measurement limit. In this sample are 6 supergiant stars. The parallax of one of these stars is only an estimate. 2 of the others are at the extreme limit. The last 3 are between 171 and 192 light-years distant. None of the most luminous supergiant stars are in this sample. Thus, all luminosities given for such stars are estimates. Even where parallax is measured, the measurement is rarely precise. Uncertainties of 25% and larger are common, leading
What happened? What happened? Oh, are you kidding me? You gotta be kidding me. It just quit? Oh, what happened now? Play this one. Yeah, play this one. This thing, man, what is up with this?
Takes on the order of several hundreds of millions of years after accretion, core of the galaxy. These disk stars are the most numerous group of stars observed. I read before the red dwarfs were, but perhaps it's a different location in the galaxy. The disk of the galaxy is enveloped in an ovoid shell of red giant stars whose spectra show fewer metals than stars of comparable type in the disk population. That these stars are mostly giant stars is usually explained by claiming that the smaller stars in the population are not likely seen because of distance from Earth. It is possible that the later are absent. Most of what is known about these stars is from the study of giant stars within star clusters, an intrinsically varying giant star, where the star's luminosity varies, in some characteristics, way over an interval of days to months. 5. The galaxy itself is embedded in a halo of cooler stars. Most of what is known of the galactic halo is deduced from a study of a few nearby small stars and 120 globular star clusters, which surround the core of the galaxy. One of these globular clusters, Messier 13, in the constellation of Hercules, has been described as a celestial chrysanthemum. Baker, R.H., page 451. The number of stars in this cluster cannot be counted.
but estimates around 500,000 are made. Averaging this number of stars over the volume of the cluster, not precisely known, it would seem as if the stars are about 2 light years apart, much closer than the stars near the Sun. Some small halo stars are observed passing through the disk stars in the Sun's vicinity. Barnard star is an example. Yeah, those stars in them globular clusters, if they do have planets, which I'm sure they do, but life might not be very easy to come by there because of all the closeness of everything. Probably just get started and get wiped out, I would think anyway. Never know, though. In summary, the most interactive stars and gas clouds form clumps, which are the galactic arms.
Hello.
Around the arms is a disk of less interactive stars.
What's going on?
Enveloping the disk are variously shaped ovoids and halos, allegedly to be progressively more metal-deficient stars. It has been proposed that the stars of the different populations of the galaxy follow
It sounds like you're
about
cutting
the
in and out,
galactic core,
but
which are
what's the
characteristic
point
of the
in this? I
population.
don't get it.
Supposedly, the arm stars have the most circular orbits. The disk stars follow.
Oh, so I just
slightly
happen to be the only one on
paths,
right now?
The galactic plane. Some are deemed to move inclined slightly to the galactic plane, like the asteroid orbits of the solar system. The halo stars move in strongly elliptical orbits with random inclinations to the galactic
Well,
arms,
it's 1:30 in the morning, so
like
that might
the
have something to
comet
do with it.
orbits of the solar system. As they pass through the sun's locality, the halo stars betray their presence by large annual displacements compared to the disk stars. All of the stars in the galaxy are in motion. Since there is no standard of rest, all we can detect is the motion of one star relative to another. Two streams of stars are observed moving past the sun parallel to the Milky Way, the arms of the galaxy. The two streams move oppositely at the relative speed of 40 kilometers a second.
Hey, I love your stuff, man.
The outer stream moving towards Orion, the inner stream to Scutum. These motions apparently reflect differences in
you want to chat on
motion of
YouTube?
consecutive galactic arm segments in the galaxy. The stars in the sun's arm,
No, that's
we
cool.
assume, move
I mean,
with the
whatever,
sun
but,
at 275 kilometers a second.
So how would
Towards
it
the
work? Like, if
constellation
everybody
Lyra,
else is interested, it'd be like 52
which
people
is a
on
motion
one
away
line
from the
talking.
stars of Puppis. Looking only at the net motion of stars close to the sun, we detect the drift of the sun within its arm of the galaxy. This analysis reveals a motion of 20 kilometers a second
So what is
towards
it?
the constellation
you and
of
me are
Hercules,
talking and
away
we're
from
going
the
over YouTube
constellation
right now,
of
then, or
Canis
what?
Major.
I'm really
Isn't that
confused.
the biggest star that we've seen? It makes the sun look like the sun makes the Earth look. Mihalis and Routley, page 103.
Okay.
Neither of the sun's motions is precise, but they should suffice for our purpose. The sun's motion within its arm carries it 4 astronomical units per year. It takes nearly 22,500 years for the sun to drift 1 light year from its present position. But when the galactic revolution motion is considered,
delivering pizzas
the sun
right now,
is moving
so
up to
I'm
14
in
times as
transition.
fast. Neither of the sun's motions is precise, but they should suffice for our purpose. The sun's motion within its arms carries 4 astronomical units per year. It takes nearly 22,500 years for the sun to drift 1 light year from its present position. But when the galactic revolution motion is considered, the sun is moving up to 14 times as fast. In the extreme, only 1,107 years are required to displace the sun 1 light year. So in 10,000 years, the sun moves 9 light years, and in 1 million years, it travels about 904 light years. If our hypothesis is correct, and the stars derive their properties from the space in which they are embedded, then a look at the stars
Yeah, thanks, man. I'm no, I've been on there since, I don't know, since my son was a boy, so about like 15 years maybe. Yeah, I just turned 52, actually. Oh, thanks. Oh, thanks. Okay. So what'd you retire from? Which one? Oh, what? Big Three Airlines? Oh, cars. Oh, okay, cars. Okay. Yeah, my dad retired from. Yeah, I grew up in a place called Anderson, Indiana. Hey, you familiar with it? Yeah, yeah, your mic is cutting in and out. I don't know. You there? Okay. Oh, it sounds like you're like it's voice activated, but it just sounds like it's dead sometimes. Uh huh. Excuse me. Yeah. Well, shoot, that was something. Somebody's here. Oh, okay. No, man. Yeah, no. I always thought, well, shoot, man. If I had this guy one on one, I'd ask him a bunch of stuff, but like, I can't think of anything right now. I'm I'm starstruck. Uh, uh,
Hi, Clayton. Hi, Greg.
hey.
Hey, man. I know how you feel, Clayton. I feel just the same way when I watch Greg's videos and I think about things that I might want to talk to him about. But now I'm actually here. I can't really think off the top of my head. Yeah, it was cool. He's from like the north, and I'm from the south, I guess. And that was.
Does it sound like Greg's cutting out? No, I was talking to the English guy.
I can pretty much hear him. It's quite abrupt because I guess he's got push to talk. So
yeah, okay.
I might be coming through now. I bet they can hear me now. Okay. All right. We had a. Can you hear me better? Can you guys
Hello?
hear me better? Yeah,
I can hear you.
Oh, can you hear me good or is it bad?
What
if I get closer to the mic? Is that better?
Seems so. Cryptomenesia.
That's what I want.
It's like amnesia, cryptomnesia, but I'm not even sure how to say it.
Okay. You have a symbol that looks like a microphone with a line through it coming in and out.
Oh, that's just my mute, so that you don't hear me, when I'm not talking.
Yeah, that's mute, and the headphones is to mute the headphones, I think. And the little cog is your settings. You can go into video and audio, or video and voice.
Okay.
Everybody says that I'm perfect now, so that's good. I guess we all have a good level. So what's going on?
So is it? So is us three like coming over the YouTube then, or what?
That's right. We're in a live stream right now. Yes. It's a little thing I'm doing. I'm getting to know my subscribers, man. I'm inviting people in just to talk,
Oh, shoot.
For a little while. Get to know you.
What should we talk about?
Whatever you want. It doesn't matter. There's no certain criteria. If you want to talk about space or the universe or cosmology or, I don't know, your vacation, whatever you want to talk about. And toss it over to Brett if you can't think of anything. It's okay.
Yeah, I can't think of anything. Sorry.
That's all right, man. That's what I love about Richard, man. This dude never runs out of things to talk about. I mean it in a good way.
Oh.
Yeah, Rick's good for talking.
Oh, yeah. Yeah, that's true. But it's not like he's babbling. He always talks good sense, I don't see too many times where he's rambling off,
He's happy to be corrected as well.
Oh,
it's like, it's cool. It's like we've got to go out there and say the things that we think and find out if we're wrong.
Yeah. Did you see the video?
Which video?
The one from Wal Thornhill, the first one, the premiere.
Yeah, you were kind of going over like his electrogravity stuff. Yeah.
Oh, I've seen that whole video.
Yeah. And there was another one too. The thing I did with Ted in the top 10. That was a stream, though.
That was a what?
I was not really. I was just kind of thinking out loud. It was a stream.
There's a guy. Oh gosh, what's it called? See the Pattern, I think.
Yeah.
That reviewed Wal Thornhill's video on. What does Wal call it? Like electrogravitics or something?
Close enough. Yeah, electrostatic effect. Electric dipole effect. There's a lot of different descriptions.
Yeah, the guy seems to know his math a lot better than I do. But I think the name of this channel is See the Pattern.
Okay, and
he reviewed Wal's. He goes through a lot of the Electric Universe stuff.
Well, what did he say?
There was something there. It was. I don't know what the. Oh gosh. I don't want to say causality loop or whatever, but it was like it was self-referencing or something to that effect. Like that was his main point or main problem with it.
Oh, so he had problems with it. Well, I mean, I wouldn't think that anybody would ever have anything 100% right,
Mm-hmm. Oh, no, he just had the one problem with it. He didn't have like a bunch of problems with it. He said it all kind of... My sense of it was... I've listened to it twice, but... Yeah. Gosh, I wish I...
That's interesting. What's his name? I'll want to check that video
out. Shoot. Man, if I had a better phone.
Gareth from See the Pattern, yeah.
What's it called?
Okay, See the Pattern.
Yeah, is that what you're talking about, Clayton? Yeah.
Yeah.
See the Pattern, yeah.
Yeah, there's a room on this Discord. There's a See the Pattern room where we've posted up all his videos, and sometimes he's on there and kind of answers questions on here.
Oh, okay, good. Yeah, he seems like
I'll have to check
type of guy that would. Yeah, he goes through a lot of the... Yeah, he's pretty good at going over the Electric Universe stuff.
Yeah, it's always interesting, and whenever I've read a lot of Wal Thornhill's writing, and I don't ever remember him once being wacky or spouting something that just wasn't common sense.
Right. Yeah, I wish I could making it sound like the guy was bad-mouthing Wal. He wasn't.
No, I know what you're saying. Yeah, and you know what? They disagree amongst each other, so that's normal.
Yeah.
Yeah.
Yeah, it seems like that's the difference sometimes with the Electric Universe, and where, you know, even with that name, it's not like everyone agrees on how electricity works in the universe. So it's like, at least on this side, you get people trying to work it out, and it just seems like so much on the main stream or on these, you know, astronomy documentaries, the kind of way they talk is they're talking as if they've got it all figured out.
Well, yeah, but if you get to the big questions that mainstream thinks that, you know, they already or know, or maybe you're one or two steps from knowing all, they say very humbly, we don't know. And, you know, that's those are things we need to learn. And I think I heard someone say this, it might have been Wall, but one of the reasons why they won't accept the electric universe is because it doesn't have a story of a beginning and how we got here. And, you know, I mean, the Big Bang gives us to it right from the very little, you know, spark or whatever it was that blew up that was nothing. But, you know, we know now that's a story. You know, the universe, as far as we know, is infinite and has been here for so long. It's ridiculous, you know? How could you possibly figure something like that out?
What was the logic behind thinking that we needed a beginning?
Yeah, well, you know, the physicists did that. You know, the mathematicians, and they got all this funding for the particle accelerators, which I still think have a different purpose. But that's all a waste of money. They're looking for gravitons and all kinds of stuff that doesn't exist.
I think it's funny in these particle accelerators that they have to use an electric current to make the magnetic field to get the particle to move around. Yeah. But they're not really investigating the electric current. They're looking at these particles. It's like, how did they even do that?
Yeah, I know.
Oh, hey, you know what? I think that See the Pattern guy was addressing how they relativistic mass, like they take a particle and they accelerate it, and the faster it goes, the more energy they have to put into it.
Yeah.
To somehow, but that, man, I don't really know enough about the theory to intelligently comment on it, but somehow that is addressed by the distortion of the electrons. I know that doesn't make any sense, but
yeah, you're right.
But the faster they push it, that doesn't mean that it's getting more heavier or more massive per se. But yeah, I don't know that. Somebody just mentioned CERN. I'm sorry. How would you like to be addressed other than the Englishman?
Just Greg, and I think he's Brett. You're Brett, right, Brett?
No, I'm Chris. You can call me Chris.
Okay. I thought you were
Chris.
Brett. I'm bad with names. Yeah, that, you know, I've often wondered, you know, what they really are doing over there. I mean, like at the Hadron, the Hadron Collider. You know, I mean, what are they really doing there? You know, they're smashing particles into each other and then see what comes out. I mean, that's like Wall said. I remember he said something that was funny. He said, that's about like crashing a 747 into a mountain and then combing through the bits to see how they fly.
There is a guy, I don't know what to think about him because everything seemed to be, I don't know, how do you put it? Like, okay, everybody's got their pet theories, okay? Like, this guy's pet theory was that all this stuff is being driven by Nazis, like actual, like, Third Reich Nazis. Okay? So, like, boys from Brazil, you know, like, people say, you know, oh, the Jews, oh, the Jesuits, you know, this guy, you know. Okay, so, like, this guy's thing was Nazis, okay? So, you know, they had that thing where they, somewhere in Poland where they were working on the UFO technology. You guys familiar with that one?
No, I'm not. I know a little bit about that stuff, but I don't know if I know about that.
Okay, there's they had some sort of research area somewhere, and there's this ring that they have, and I can't really tell you how wide it or what the diameter of it was, but I mean it's big enough to where you got the drawings. There's supposedly 3 types of Nazi UFOs or German UFOs, however you want to put it.
Oh, okay, yeah.
And then are you familiar with the Foo Fighters?
Well, I am familiar that what was happening, but I never really heard the lowdown on what it turned out to be. Do you know that?
I don't know if they actually figured it out, but the guys in the bombers and the American bombers, and I don't know if it happened at night, but the Americans were the ones that were running the bombing runs during the daytime. They had these Foo Fighters. They would be points of light, which would be what we would say are UFOs, and I don't know if any of them ever did an attack run on any of the bombers, but supposedly they were just they would hover and then they would move like you would see. People would report UFOs to be able to move straight up or suddenly off to the right or whatever, that sort of thing, not moving like a normal airplane would. But back to, okay, so say that was the German Nazi UFO project. There was some place in Poland where they were working on that kind of stuff, and there is still a ring there that had like a bunch of wires in there, and electricity. You can generate a magnetic field. So the idea was that they were working on some sort of way to levitate that. And this guy's idea, about get back to what we were talking about with CERN, was they were taking that and just making it like a bazillion times bigger. And what they're trying to do is possibly open up a gate.
Yes, I've heard this, yeah.
Yeah, so, and that's where it starts getting a little non-scientific there.
Right, yes. And you hear things, and some of them you take with a grain of salt, but if you hear something, the first time you go, oh, that's kind of ridiculous. And then you'll learn something else that's connected to that, and it'll like add up for that to happen. And eventually, before you know it, you find out it really happened. So you just don't know.
Yeah, that's the way I described it to a buddy of mine, because we were talking about conspiracy theories, right? "Quote unquote" conspiracy theories.
Yeah, right. Yeah.
And you sit there and you hear something, it's like, oh, this guy had a rabbit that would pop out of his ear. Okay, so you just put that in a little note in the back of your head, and then 3 months later you'll hear some kind of reference about rabbits popping out of people's ears, and oh, okay. And then at some point, then you start looking into it and wasting hours and hours, looking into this. But you can't really follow every weird thing that you hear,
Yeah, I know. There are so many people, they put in that a lot of hours with the whole Nazis in Antarctica thing, and the admiral went down there and got his butt kicked, and I just don't buy that. I don't see any evidence for that.
You think that guy, God, what was his name, Byrd?
Yeah, Admiral Byrd, yeah.
Yeah, you think the films were all faked?
I've never seen any of the. I mean, he's got films. The only films I've ever seen of him is when he's on that television show, and then they have a few pictures of him when he was a strapping youngster, But I've never really seen any films. No.
Oh, they got documentaries on it. But they can stage whatever they want. You could just take a picture of a plane, taking off in the water or whatever. I mean, it really doesn't prove that they did any operations, to whatever end or whatever.
Yeah. Greg, you did a video where you mentioned about black triangles. Is that what you kind of call them?
You mean TR-3Bs, the secret space program, the black triangles? Yeah.
I mean, I was I haven't really researched it, so I wasn't sure. Clearly you've looked into it a bit, so you think there's genuine stuff there, or I guess we can't be sure exactly?
Oh, I absolutely do. I think that they most likely have conquered gravity, and I think they've probably had it since probably the 60s or the 70s. Because
maybe
Bellfield's ground propulsion, man, they were doing it in the 20s and 30s. They almost discovered anti-gravity before they did airplanes.
Wow.
It was always just a secret, because they were toiling away. Well, at one point, at some time, they had a breakthrough. And then probably followed by another break. You know how it is. You usually just stumble onto them.
Do you think they're suppressing that to keep the scarcity economy going and therefore keep power?
Well, I don't know, to be honest with you. I mean, there are a lot of ramifications that would come about. Let's say if it was to say tomorrow, all right, as of June 1st, we're going to be on total electric power, no more gasoline, no more oil. Well, what would we do with our cars? What would people do that are working in petroleum? It's probably millions. I mean, you would all of a sudden have no economy. I mean, the world's economy was built on the automobile.
Mm-hmm.
The automobile in war.
Right. Most of the wars. Well, actually, I don't know if it's really done over resources 100% of the time. You probably can't say that, but if say you got a telephone, and the guy makes the telephone. Okay, let's just say a pair of shoes, just make it simple. So the guy's got a pair of shoes. Okay, like if this guy could go to the grocery store and just get food, and they would just give him the food enough to feed his family, would this guy still make shoes? Okay, that's where you get the economy. Okay, so like that's how your economy works. Okay, so this guy's working to get money, to get food, to feed his kids. Well, if you gave him the food because the farmers just did it because they didn't have to pay for fuel to run the tractor, like a lot of your cost in an item is energy cost because you had to transport it, you had to, run the furnace to melt the metal or whatever. If all that was free, if the power was free, things would get to a point to where it costs 1 penny, and what would be the point at that point?
Eventually, everything would reach an equilibrium. I see your point, but how long would that take? If it just went into it has to be phased in, I would think. That's just what I don't know. I could be wrong. But they couldn't just go cold turkey. I don't think, because what would you do with your cars and it's just so much, all the jobs, and I don't know. It's hard.
Well, you could still use your car.
I mean, they could phase it in. Like, first of all, make it to where you don't have to pay an Edison bill. But then there's hundreds of thousands of people that work for Edison. They're going to be out of work. It's plus, but not really, because Edison would be needed more. So I don't know. See,
well, I mean, they could run the Tesla towers, right?
Yeah, right. Oh, hey, I'd be all for it, But having lived my life in the automobile business, I would be worried about the people that need those jobs. That's just what my thinking would be at first. They would have to be re-educated or put into the electric car business or whatever car would be out, the flying car. I doubt we'll have flying cars because people are crazy.
Right. I don't know. Is there an advantage to an electric car other than?
Well, it's clean on the environment. They're always talking about global warming and all that crap.
Right.
I
mean, assuming that's a hoax, would there be any reason to not use an internal combustion car?
Sure, they probably would. I mean, I think honestly, that one day in the future, maybe 50 years from now, maybe 100, but I believe that people will be able to transport across country in just the blink of an eye. Dollard talks about it. They talk about frequency and resonance and making spooky action at a distance is actually an electrical resonance with two electrons or two atoms get into phase with each other, and what happens to one happens to the other, whether it's next door or on the other side of the universe. Well, the thinking Eric Dollars that he was partaking on it in the 60s was they were trying to match the resonances from New York to LA, where you would have both machines on. You would step right into LA from New York and then shut New York off. That was what he was talking about. I think it's probably going to be doable in the future. Might be 100 years, but they're going to do it one day.
Huh.
It's not about molecular structure. It's about lining up the resonance and the frequency of the electrons or the atoms or the ether, whatever it is that gets in resonance with each other, and they will, standing in one, technically you'd be standing in both at the same time.
Uh-huh. Okay.
Dollard explains it much better than I do. He called it something, and I don't want to get it wrong, but it's something like integratron or something like that.
Okay.
I could be wrong.
Yeah, and even it seems to me what they're saying in the electric model is that the whole Earth has this kind of electrical current and circuit. Particularly, we see it in the magnetosphere, I guess, and the current going through the poles, that there is something traveling around the Earth, there's energy. So it's kind of almost like there's something already going on, like what we're trying to build, like that things can already, I don't know, something maybe consciousness can travel or something is traveling very fast across the world, but we're not really aware of it.
Yeah, have you seen, do you know who Rupert Sheldrake is?
Sure, yeah, the morphogenic.
Sure.
Yeah, morphogenic,
I wanted to try and find it. There's a panel that he did, the Electric Universe. I really need to get it right, though, but I think someone in it is sort of making this point that the electric current model, it almost replaces the morphic field model. I don't want to be controversial saying this, but it's like, because the morphic field comes from chemistry. It was an idea that they proposed in chemistry, and it just says that molecules in different parts of the planet are somehow resonate with each other just because of their shape. But it doesn't really say how they do it. But the electric model does, in a way, propose a bit more than the morphic field, because it's saying that there is a current which provides a method of transmission of this information.
Well, the chemists always say everything's a chemical first.
Yeah, I mean, the chemist thing even is just charge. That's all electric charge. Like acid is a negative charge, alkali is a positive charge. And I think that's something that there's a lot of, there's like a huge amount of work to be done to try and marry the ideas of electricity with the ideas of chemistry, because they're not. And when we look at materials ionized, then it's acting like a plasma. So, I mean, I don't know about this, but it seems like, plasma has implications to other materials that we don't think of as plasma, but they have electric properties, and they're kind of like that. Like sorry, go on.
Go ahead.
Oh, I don't know. I was just thinking they talk about the plasma currents in the lava under the earth, or this kind of thing, like electrical
That's weird.
currents.
That's what I was about to say.
That's not what we really think of as like high energy arc discharge plasma. And I was thinking about, how do you put electrodes? How do you measure like electric current through a plasma? Because through a lava rather, because like you're just going to melt anything, right? You put on, I don't know, but they have electrode smelters. They have electric smelters, don't they? That melt stuff into liquid rock by using electricity. So like, maybe this is the I'm just taking what I've heard on these like electric geology talks and stuff.
Oh, so that's the whole thing.
There's current, like going through the lava.
Oh,
and that kind of explains like where we think there are plates meeting of the continental plates. That it's more like maybe it's filaments. It's sort of a channel of current going between the poles through the plasma, and that's why it follows along a path like it does.
Okay, so that's a little bit different from what Eugene Bagashoff was saying.
Oh, okay, maybe. What does he say?
He's okay. There's like all living creatures need some sort of a power source, right? We get it from breaking down food, and his gosh, how does it go? His proposal is that any of your tectonic activity is an electrical discharge from creatures. I don't know if creatures, but like microbes, perhaps.
Because of the ultra deep biosphere.
That's it. Yes. Are you looking that up right now?
Oh no, I've watched those ones. Yeah, and then I posted something up about these electric cable bacteria that have been found. That these bacteria that seem to act like electric cabling. There's all sorts of crazy stuff about it, because like in Eugene's video, he says like we don't really know a lot yet about how much living stuff there is deep underground.
Right.
There probably is a lot.
Well, tying back to cars, I was just wondering, I didn't hear anybody talk about petroleum. And, like, they really don't know where that comes from. You know, the whole idea that it's a dead dinosaur, really, you know,
no,
whatever.
The Earth's natural lubricant. That's what I'm told.
Yeah, I heard that it was supposed to be like the lubricating the joints or something. And some people think it is a biogenic, or is that the right word? So it's that it's somehow produced by living things. So it's not like it's not actually made of. I don't know. It's hard. I don't know. But what I like is at least we're questioning these things, and it's not like we're saying, yeah, we definitely know how many millions of years, you know, the oil is whole.
There's a guy named Fletcher Prouty who knows a lot about that. If you ever want to watch one of his interviews, he's got a lot of pretty eye-opening things to say.
How do you spell that?
Well, there's Fletcher, so it'd be Fletcher, Prouty, Prouty. T is in Tom. Prouty.
Cool, thanks.
Yes, I mean, just an amazing mind. You'll see. When he worked at the Pentagon in 1963, before John Kennedy was assassinated, gamed out Vietnam. And they gamed it out to last for 10 years and cost 57,000 lives. And I mean, they called that 2 years before. Well, we just had advisors in there, so it came out exactly like they said, except for there was 1,000 more that died. It's crazy.
How did they do that?
Well, they gamed it out, the military. I mean, you know, the War College and all that. You know, they got people that just dissect that stuff and take it down to the whatever, you know, to the furring strips. I mean, you know, they just love war.
Right.
And they gamed it out right. It's like a bookie calling a game. You know, usually ever notice the games are usually always within the spread? These bookies know something.
Huh.
Not that I gamble, but I've known a few people that had gambling problems, and it was just sick watching them. I mean, it was pitiful. It was pitiful. People betting their freaking paycheck on a basketball game. That's just so ridiculous, man.
Yeah, my roommate was talking about there was a fight here recently that the guy that was long shot got it, and he should have bet.
Yeah.
I'm just kind of curious as to like what sort of methodologies they use. I mean, were they gazing into a ball of water in the basement of the Pentagon, or what?
I don't know. You know, they were probably looking at the logistics, and you know, I mean, they went through 5,000 helicopters. You know, Bell and Howell and General Dynamics. They made fortunes
and oil well, all kinds of stuff, man. It's just ridiculous. I mean, if someone was attacking our backyards and threatening us, yeah, I mean, I can see defending ourselves, but I mean, just going because somebody doesn't like you, you're gonna go bomb them, children. I mean, I just don't get it. I don't understand the logic in it.
Money,
of course, but I mean, people are that freaking greedy. I wouldn't accept money like that under those circumstances.
Yeah, the people have got a different mindset.
I see that. They have no. It seems like they have at some level, they have no regard for human life whatsoever. Their own side, the other side, doesn't matter.
Oh yeah. Well, there's a studies where they have they take people. I don't know how much stock you put in psychology, but
I know a little bit about it.
Oh, do you? Okay. Well, what? Gosh, what's the? It's been years. What's the deal where they sit there? They ask you like how much you make, and then they pair you up, and then like people in lower strata tend to be more cooperative, and then they'll keep getting more and more money. But if you're playing against somebody who makes over X amount of money, let's just say 100,000 a year or whatever, that just increases the chances that at some point that guy's gonna flick the switch and screw you to win instead of keeping the cooperation going. So there's like a definite change. There's different ways of looking at things, even though we got the same brains. But the people that that would do crazy things like run planes into buildings or whatever don't think like most people do.
No, they do not. Yeah, you're right. They
just look at it as like, what are we trying to accomplish? How do we get there?
Yeah.
What do we got to do? And then they just do it.
Right. Yep. I found this little recording, an audio by Dollard, where he explains this device. It's only about a minute and a half, 2 minutes long. I'll play the audio. I just want to show that. I don't want to. I'll just play it for you guys to hear it. It's pretty good.
Is this playing on YouTube?
It's a video I have.
Prelude to a situation where electricity will disappear in one physical location and reappear at another physical location without anything going on in between. In other words, a true action at a distance. And as far as like the conspiratorial or theory go, I would go so far to say that two properly constructed devices based on Alexanderson's principles, if you have one antenna in San Francisco and you have one in Los Angeles, and everything was tuned up right, that if you were standing in the one in San Francisco, you would be simultaneously standing under the one in Los Angeles as long as the generators were running. That is the implication of that particular technology or engineering, and that's what makes it worth studying.
Could you comment if the Philadelphia experiment might have been a variation of that?
Well, see, the Philadelphia experiment I don't know about because that's not there. You know what I mean? But yeah, the Philadelphia experiment would have to be, it would be something similar to that, but it'd be more like that Integratron. But we're starting to get into that direction. That's what we're starting to get into. What it is what Alex Anderson had done, the picture of his patent,
I don't want to play too much of it, but that's the gist of it. And I will link that video in the description for you guys to check out. It's very interesting.
Okay, I'm sorry I missed it on the phone here.
No, that's okay. You can hear it next time, But it's really good. I mean, like I said, I like listening to Eric. He's amusing and he's funny, and he knows his shit, obviously. You know, like the electric force is also the creative force, you know.
Mm-hmm.
Yes, I think that's pretty amazing.
Hello?
Yes?
Hello?
I'm just trying to let you talk.
Oh, okay. Sorry, there's like a little bit of background noise there, and then when you quit talking, it just cuts out. It sounds like it's dead.
Oh, yeah. You know, that's cool.
Okay. So, what was the gist of the video?
You'll have to watch it. It's hard for me to explain.
Okay, I understand.
Yeah, I mean, it's about spooky action at a distance, electric universe style.
Okay.
Yeah.
Oh, it's got to do with that. What did you call it? It wasn't a transporter.
Basically, it's the same thing. It's just not
Yeah,
like
same.
Star Trek has it. You know, it don't tear your
Right,
molecule.
where you have to.
Yeah, it has nothing to do with that.
Okay.
He's talking about having two generators that they link, when they're linked up, resonance and frequency wise, and if they were both running, you could be standing in two places at the same time. You know, and it sounds real science fiction, but what didn't sound like science fiction before, you know, it was done?
Right.
I got a few things written down here I found they're pretty good. Let's see. Where is it? Go ahead. If you guys, anything comes to your mind, just spout off. I picked something up here. It is the global dynamics and systematic interactions of astrophysical plasmas that allow energy to be conveyed over great distances. The evolution of cosmic plasma that includes its structuring into cells results in a relative motion, however slow, of plasma clouds, whose dimensions may be measured in hundreds or megaparsecs. All plasma clouds may be considered a system. They are coupled by electrical currents, charged particle beams. They induce in each other. These beams are the source of energy transfer from large, slow-moving plasma to smaller plasma regions that may release the energy abruptly or cause local plasmas to pinch to the condensed state. And you can tell them I said so. That's the dynamical characteristics of plasmas. I believe it was written by Tony Perrett. I'm not sure on that, but I think that I forgot to write his name.
Greg, I just wanted to shamelessly plug a music video that I made.
Yeah,
that
sure,
it's called Plasma Cloud, and it's on YouTube, and it's for music by a guy called Doobie Dolchek, and the song's called Plasma Cloud. It's pretty easy to find if you type Plasma Cloud into YouTube.
Okay, yeah, no doubt, man.
I can send you
a link to it in the description.
Oh well, you know, it would be good to get some views. It's not had many views.
Okay, well we can change that. We'll try to give it some views.
I'm gonna message it to you.
Okay.
It's just because you mentioned plasma clouds, you know. Well, we all like plasma clouds here, you know.
Yeah. Have you gentlemen ever seen the Jupiter Myth? Have you watched it at all?
That's different from the Saturn. hypothesis?
Well, it's the same people basically, but it's the continuation.
Jupiter was a star, and somehow Saturn captured it.
Well, yeah, I mean they're talking about a jumping Jupiter where it was really electric. You have to watch the video. It's hard for me to. It would be hard for me to explain.
Okay.
It's about Saturn theory, but Jupiter's role in it.
Yeah, I'd like to see an animation of all that because.
Yeah, that would be. Awesome.
Well, here's the thing. Okay, so like I get that. Okay, so we were inside Saturn, and then we got spit out at some point, and then Venus gets kicked out of Jupiter, and then starts making close passes, and then we get electric, like hit with electric bolts every time that happens, right? And then Mars and Venus get in a fight, and then at some point everything chills out. I get the general narrative of it, but I'm not really picturing like how those orbits would work. I mean, if somebody could come up with a cartoon or something, that would probably help a lot of people. I think that it's so fantastical.
I don't think he'd mind if I played a little bit of it. It's really good. I mean, I love it. It doesn't have a lot of bells and whistles, but it's chocked full of information. I'm trying to find it right now.
Yeah, it's kind of hard to pin down the specifics and the timelines and like the orbits, like you say, and it's a tendency in the mainstream that they like to say, this is how it is, but it's kind of refreshing in a way with the electric stuff that it's like, well, we can see all sorts of reasons why it might have been this or that, but we can't. Well, it would be if you made up a narrative, and then the tendency would be to try and stick to that, and then that would cause the same kind of complications that we're in now, where we're trying to stick with something that's become popular.
Mm-hmm.
So, but yeah, I mean, there's that Myths of History YouTube channel goes into that Jupiter myth
That's
stuff.
exactly what I'm talking about. Yes,
I'm not even that up on the Saturn myth. I haven't read all of David's books, and
well, there's many ways it could have happened, but what he posits is that wayward Saturn, sub-brown dwarf star, drifted into the sun's Birkeland current, and then at the time Jupiter was either a hot Jupiter or a sub-brown dwarf star itself. It was 0.34 AU from the sun, which meant its moons were in the comfort zone. So, then there could have been all kinds of possibilities on both systems, But because Earth has dinosaurs and all these meat-eating monsters, it's hard to imagine that humans could have been native to this world. Because we needed a peaceful world.
Because there were big dinosaurs around.
Yeah, I mean, I don't even know if an elephant gun would bring one of them down. I don't know.
Well, maybe with the different gravity, if there were people when dinosaurs were around, the people were a lot bigger, giants, and they were giants.
Yeah, giants.
Then the dinosaurs would have ran like the squirrels do.
Because always an intuitive thing, from the Flintstones. It's like no one ever said there were people and dinosaurs together, but somehow it seems to look right to people. Like people are like, yeah, it looks okay. But
I'm trying to find the one that I want. I'm having a hard. Oh, wait a minute. This might be it. Hold on. I'll play a few minutes of it and see. But I'll put the link in the bottom and check it out. It's really good.
Okay, I'm not looking at YouTube. If you could let me know when you're done with the video, then I won't interrupt it.
The Nice model suggests that the radial migration of Jupiter and Saturn continued to excite the orbital eccentricities of terrestrial planets like Venus and Earth. If Venus and Earth had more dynamically excited orbits back then, the study of the evolution of the terrestrial planets during the changes of the giant planets' orbits is a key to unveiling the real evolution of the solar system. Venus, like Earth, had earlier been displaced from the former polar alignment and was shedding charge in order to acclimate to its new solar environment. Appearing as a stupendously large comet day and night, Venus was obsessively tracked by early...
Let me put the video on. Hold on.
Okay.
The Nice model suggests that the radial migration of Jupiter and Saturn continued to excite the orbital eccentricities of terrestrial planets like Venus and Earth. If Venus and Earth had more dynamically excited orbits back then, the study of the evolution of the terrestrial planets during the changes of the giant planets' orbits is a key to unveiling the real evolution of the solar system. Venus, like Earth, had earlier been displaced from the former polar alignment and was shedding charge in order to acclimate to its new solar environment. Appearing as a stupendously large comet day and night, Venus was obsessively tracked by early astronomers, watchful of potential conjunctions that might align Venus and Earth along the plane of the solar current.
It's 7 minutes long.
Such conjunctions could only fall on an equinox when both Earth and Venus were transiting the ecliptic. Passing in front of the Sun on the day of the equinox, a Venus transit would eclipse the Sun at the same time as its extended plasma tail would make contact with Earth's plasmasphere. Superimposed charge sheaths would expose both planets to an intense repulsive shock, compressing and contorting huge stretches of land and sea, pushing Earth into a wider orbital ellipse with its axis torqued in gyroscopic response. Each time Earth was propelled away from its former orbit, its charge potential would acclimate to the Sun's electric field once again, and extensive flow vortices at both poles would radiate intense aurora funnels and toroidal columns. These plumes would have been visible day and night to everyone on Earth, extending out from the poles and trailing away for thousands of miles through Earth's plasma tail on the night side of the planet. The plume extending from Earth's south pole was particularly associated with Jupiter, seen nearby in southern skies, becoming enshrined in myth as the thunder god's war bow, long cane, or right leg. In the Kabbalah, this is the right leg of Yahweh, the phallic foundation pillar in the center of the southwest. In all mythic references, the Jovian war bow dramatically reappeared during or immediately after large-scale Earth cataclysms. Its peculiar bend along the tail of Earth's charge sheath became a strange but commonplace motif in the iconography of many cultures. Often invoked in antiquity, in 2009, NASA's Themis satellite rediscovered these plasma plumes in dark mode, bending up into the magnetosphere on the night side of Earth.
You guys aren't seeing it.
Venus-Earth conjunctions could also potentially
I'm just going to put the
unleash a
light show,
battery of
the
electrical
slideshow back on.
exchanges. Having no intrinsic magnetic field of its own, Venus's induced charge sheath could have conducted plasmoid discharges along its extended comet-like plasma tail. Twisting and contorting in blinding arc mode discharge, a string of plasmoids frolicking in the cloudy fire waters of space surrounding Earth closely matches descriptions of dragons remembered worldwide. These dragons likely roam the skies during every Venus-Earth close encounter. On one such occasion, an equinoctial Venus-Earth conjunction unleashed a furious dragon into the debris ring surrounding Earth.
I don't know why it won't show.
When he sneezes, light leaps forth. His eyes are like the eyelids of the dawn. From his mouth come fiery torches. Sparks of fire fly out of it. 100 snakeheads grew from the shoulders of this terrible dragon, with black tongues flickering and fire flashing from the eyes. When the dragon stands up, the waves themselves take fright. The billows of the sea retreat. He churns the deeps into a seething cauldron.
the stream? I don't understand.
It makes the sea fume like incense. Upper ionospheric discharges, red sprites, followed, remembered as a barrage of red arrows shot in defense of Earth by Jupiter's warbow, Earth's own south polar plume appearing simultaneously in the skies in response to Earth's widening orbit. Thunderbolts racking the sky, Earth was violently convulsed. Tilting up in the sky as Earth torqued off axis, Earth's debris rings were broadsided by the disconnected bolts, streaming across the sky in gaseous glowing envelopes that gradually descended through the ionosphere in downpours of sparkling spatters, some falling to Earth in streaks of bright red. It is here suggested that this is the origin of the mythological motif known as the shattering of the vessels, the release of the waters, and the second flood. Mysticisms of later ages, including the Gnostic schools of the major monotheisms, still evoke memories of the falling sparks that descended to Earth from overhead after a cataclysmic cosmological drama brought creation to an end. In the Kabbalah, such references indicate that there were 7 vessels which shattered. Other sources suggest 9. The 7 or 9 swirling, back-flowing streams of Okeanos similarly withdrew from encircling the Earth when boiled away by the burning blasts of Zeus. In the Enuma Elish, it was said that the institution of kingship was lowered from the sky for a second time after Marduk's battle with the dragon. Jupiter seems to have again developed a mountainous plasma expulsion from its south pole soon afterward, perhaps in response to the plasmoids released by Venus, or perhaps simply in a further attempt to reach equilibrium with the electric field of the Sun in the space beyond the asteroid belt. An outlying remnant of Earth's former equatorial debris appears to have remained suspended as a narrow, ruddy-colored band for some time thereafter. Much less impressive than the rings of old, this band, often personified as a world-encircling serpent, nevertheless served as the nighttime sun's daily adversary. Referred to as the River of Blood, or the Red River, the Egyptians called it the serpent Apep, or Apophis, a continual threat, constantly repelled by Re but never killed. At the end of every night, Apep was shriveled and burnt up by Re, but he was able to renew himself daily. The unordered realms of chaos were thus never completely abolished, but continued to surround the orderly world on every side. Each day brought both a confirmation of the established order, as well as a forcible reconquest of it. The world-encircling snake was also a key visual reference toward the pinpointing of equinoxes. While the bloody serpentine river remained fixed along the equatorial plane in the south, the tilted glowing hoop of zodiacal light along the ecliptic would be visible below the red ring during summer and above it during winter. But at both equinoxes, the glowing ecliptic would visually cross over the remaining red ring. Nibiru, the crossing place, refers to this visual intersection of the equator and the ecliptic, which twice a year indicated the position of the equinoxes for our ancestors by luminously bisecting the night sky. This was seen as the crossing of sky bands in Mesoamerica, that is, the confluence of the equatorial River of Blood and the ecliptic River of Pus.
Why the screen
it
went out.
was also explicated in an otherwise puzzling passage in
Please
Plato's
restart
Timaeus,
your computer.
which references the visible
Audio
crossing
render
of
what?
the motion of the same,
We
or
might
the
have to
equatorial
restart.
ring, which
I'm
is
having an
always seen
audio
plumb
error.
along the horizon, and the motion of the diverse, or the glowing band of the
They
ecliptic,
probably can't hear
which seemed
anything.
to shift position nightly, moving from west to east on a diagonal. The demiurge Zeus joined these to each other at the center like the letter X. In the Enuma Elish, it was Marduk who founded the station of Nibiru to determine the heavenly bands. The name Nibiru was likewise applied to Jupiter explicitly as Marduk's star, when he periodically stood in conjunction with Earth on the equinox in visual alignment with the equinoctial intersection of the red ring and the glowing ecliptic.
It was a long 7 minutes. I got it. You know what? I got no screen on the live stream. Can you guys hear me? You can see in here because my screen is blank. Oh, wow, that's cool. I could have showed the video. My screen, it says audio render error. Please restart your computer. So it's just a glitch on what it's showing me. Okay. Plus my live stream health is red. Oh, poop. I could have showed that. Oh, well. Okay, fellas, back to the talk. Maybe that'll give you a little bit better of an idea. Are you guys there? Hello? Hello? Well, they're both still in the room. They need some kind of like a wake-up horn. Hello? Okay, I'm not hearing you guys. I see you're lighting up, so you must be talking. Yeah. Something's going on with my computer. Okay, stay here. I'm going to be back. I'm going to restart. I have to, because I'm all messed up. I can't hear anything. So just hang with me. I'm going to do it as fast as I can. All right, I'll be back.